Hello, I'm Madhu Sudhan. I'll be doing a very small concept in geography. So here, very importantly, this is a very basic one which is actually necessary for us to know about the major coordinates and also the locations on the earth. So for importantly, if at all, if I take an earth, so if I want to locate a place A, so how do we actually locate this place or a person who is at the point A? So it is very difficult for us. For that itself, we are dividing the earth into two hemispheres by drawing a line at the center. So making that as a northern hemisphere and a southern hemisphere. Alright. So when we draw this line, we call this line as an equator. So we call this line as an equator. So now it is very easy for us to tell that location A is in the northern hemisphere. But the question arises when we have one more person, maybe B, is on the same hemisphere. So for that itself, we draw a lot of lines that are running parallel to this equator on the both hemisphere. But how many lines can we draw is the question. So those lines we actually draw usually tells, for example, if I tell this is the first line, this is the second line, I can tell that A and B are placed on the second line in the northern hemisphere. But how many lines can we draw? So for that itself, the very first lines what we draw parallel to equator is what we call it as your parallels of latitude. We call it as parallels of latitude. Alright, the major question is how many lines can we draw? Right? So importantly, it is nothing but it's the angular distance. What is the angular distance? It is the latitude I'm talking about. It is the angular distance from the center of the earth to the surface of the earth. All right. So I'll just explain you what do you mean by this is. See, very simple. If I take this as the earth, what I told, it is the angular distance from the center of the earth. Yes, this is the equator what we have drawn from the center of the earth. The angular distance on the surface of the earth, for example, this is the 1 degree. Alright, so this is what we can tell it as your, or else I'll just write it here. 1 degree. This second line 2 degree, next 3 degree. So like that, if I keep on write, I can write almost up to 90 degrees. So on the other side also, what we can do is I can draw one line that is for your 1 degree. So if I want to make you little have a clarity, so this is 1 degree latitude, 2 degree latitude, 3 degree latitude. Like that, I can draw 90 lines on one hemisphere. Similarly, 90 lines on the another hemisphere, including we have equator. So totally we can have 181 latitudes. So it is very simple that now person A or B both are placed in, I can tell since it is in the northern hemisphere, 2 degree north latitude. Alright, but I want to differentiate the location between A and B. Right? So for that, what I have to do now? Now we are doing in a different fashion, that we are dividing the earth into two hemispheres, not as northern and southern hemisphere, but as a western hemisphere and eastern hemisphere. Alright, so this is what the lines that we are drawing from north to south. Earlier lines what we draw from west to east, now we are drawing from north to south. This is what it is dividing the earth into two hemispheres on the eastern and western hemisphere. So to be precise, prior to that, about the parallels of latitude, what I told you is it is the angular distance from the center of the earth. Yes, we are able to draw the angular distance like 1 degree, 2 degree, 3 degree, like that up to 90 degrees. So we have 90 lines running parallel to the equator and 90 lines running to the parallel to the equator in the both hemisphere, right? So this is what we can see it as your parallels of latitude. But to know the difference between A and B, where they are placed, what I told you is we are dividing the hemisphere into Western Hemisphere and Eastern Hemisphere. So the very first line, like how we told as is the equator, the line which is dividing the Western and Eastern Hemisphere running from the north to south, we call this as Greenwich Meridian, or it is also called as Prime Meridian. Okay, also called as Prime Meridian. So now let's see how we can draw such type of a lines that is running from north to south. Okay, so now just keep it in mind that yes, we have earth, we drew equator that is running from west to east, and we saw that person A and person B are standing on the 2-degree north latitude, right? This is your 0 degree. So why we are using degree? I told you it's an angular distance. Now what are we doing? We are dividing the hemisphere into north and south, east and west, which is line running from north and south. Now this is the lines which are running actually not parallelly but in an angular distance from the west and eastern side of the prime meridian. That means, what is the thing I'm trying to tell you is, we are drawing many number of lines which are running like this, that are just like running from north to south, just like your Greenwich Meridian. Alright, so like this, how many lines can we draw? So if I tell this as your 0 degree, that is your Greenwich Meridian, how many lines we can draw on the eastern side, how many lines I can draw in the western side? But the point is, the lines which we draw like this running from north to south, we call this as meridians of longitude. Meridians of longitude. Alright, so now the point is, as I told you, this is also the angular distance. This is also the angular distance from the center of the earth, that is east or west of Greenwich Meridian, that is your prime meridian. So what do you mean by this? I'll explain you. Look at this. If I want to tell you, now see here, what am I drawing here is, yes, this is the equator, earth. Yes, this is the front side. The dotted line is what that is trying to mention you on the other side. So it is the equator. Alright, now we have Greenwich Meridian. As I told you, this is your 0 degree longitude, right? So the point is, from the center of the earth, if I take this as the center of the earth, the first degree we will be having is 0 degree. Now I'm going western side and this is eastern side. So 1 degree, are you understanding? Like this 2 degree, this is 1, 2, 3, 4, 5, like this it goes up to how many degrees I can cover is totally I can make it a 360 degree. Correct? No? If I have to make one complete circle, it is the 360 degree. That is what I mean it as your angular distance from the center of the earth, alright, of the earth, either east or west of the Greenwich Meridian. So I can draw 1 degree, 3 degree like this. It goes 5 degree, 6 degree like this. It completes the complete circle. So what I can tell you is, the number of lines we can draw like this on both the hemisphere from north to south is what we have is your 360 degree or 360 longitudes. Point you have to keep it in mind is, here, unlike in the previous case what we drew in the place of your parallels of latitude, we kept equator as exclusive and 90 latitudes on the hemisphere, northern hemisphere, 90 latitudes on the southern hemisphere. Totally we had 181 latitudes. But here, in this case, here we are having 0 degree. Yes, since one complete circle makes only 360 degree. We cannot have 361 longitudes. So what is happening is, your whatever the lines which are running north to south on the western side, we can call this as your 1 degree west longitude, this as your 2 degree west longitude, like that it goes, and we will be having 180 degree west longitude. Alright, similarly eastern side, 1 degree east longitude, 2 degree east longitude. So like this it goes on, and we will be having 180 degree east longitude. So the point is, the 180 degree east and 180 degree west will be overlapping. So for that we will be having only 360 longitudes. Alright, so now it is easy for us to differentiate the location of A and B. Very simple, you can observe here now. Alright, now just see here, Mr. or place A, yes, that is in the 2 degree, I'll write it here, place A is placed in the 2 degree north latitude. Since B is also on the 2 degree north latitude, now it is easy, since we are writing the longitudes, it is easy for us to mention or coordinate, locate the coordinate of A. For example, he will be placed in the 2 degree north latitude, and this is the first 1 degree east longitude. This is the location of A. Now it is easy for the location of the B. Yes, same 2 degree north latitude, but it is on the western side of the Greenwich meridian, so it is 1 degree west longitude, 2 degree west longitude, so I can have here 2 degree west longitude. Alright, this is what we have it as your imaginary lines that we are drawing on the earth to locate the places, or it is also applicable for the satellite that we are launching, how the coordinates has to be, and even for the missile testing purpose. Lot many number of applications are there. Whatever, for example, you can use your global positioning satellite, whatever the GPS we use, there also it is used, your latitudes and longitudes are very much used to locate any place, and these coordinates are very important. Alright, even for your mapping, and even in the territorial borders that has to be demarcated. Alright, so the point here is very simple. I'm just trying to give you a good overview. So we have something, imaginary lines that is running from west to east, that is what we call it as your parallels of latitude. We have that is almost 181, so that is what we will be making the earth division into in a horizontal way. And we have something called meridians of longitude, which are running from north to south, where your lines are just running from north to south on the either side of the prime meridian. So we have your 360 longitudes. But the point here is very simple. We have to make sure that as per the UPSC and KPSC examination, so this is the basic concept, but in the angle of UPSC and KPSC, it would be appearing to be quite different. So for that, I'll just take 2 minutes to draw the diagram. So we have this as equator. Just for the reference, I'm writing 1 degree latitude, 2 degree latitude, 3 degree, like this. We are having 90 latitudes. I'm not drawing the entire 90, just for the understanding I'm writing. So these are your latitudes, like this, up to it goes 90 degree. Okay, now we have to have longitudes. So that is your Greenwich meridian, so that is your prime meridian. So we are having 1 degree east longitude, 2 degree east longitude, like this it goes. Okay, so like this it is going on the both hemisphere. Okay, all right. Now the point you have to understand in the angle of UPSC and KPSC is, this is your north pole, south pole, this is west, and this is east. All right, cool. So now if we are going from equator towards poles, look at this, we are going from equator towards the poles. Yeah, so what is the point is, when I am going, so if I take latitude and longitude, so importantly the length of the latitudes, look at this, as we go from equator towards the poles, what is happening, this is running circumferential fashion. All right, so the longest latitude what we can have is obviously the equator. So as we go, since the curvature of the earth is like this, the length of the latitude that is above the equator, the 1 degree, 2 degree, like that, the length is nothing but the circumferential one which is going till the poles. That is what is going to decrease. Can you observe here? As you go from equator towards the pole, you can observe the length of the latitudes, that is the equator is the largest one. Above that, the length is decreasing because of the curvature of the shape. Yes? So it is decreasing. So the length of the latitudes, if we go from the equator towards the pole, it decreases. On the other hand, look at the longitudes. So longitudes are running from north to south. So since it is also a circumferential fashion, but unlike the latitudes which are parallel, this length of the longitudes is going to remain same. That is not going to change. Even if I am taking the 1 degree or 2 degree longitude, it is going to run from north to south, so it is not at all changing. Alright, so the length of the longitudes don't change even if you go from the equator to poles, or if you are considering only the longitudes. Now the distance between, let me call you something called distance between. What do you mean by distance between? Here you can observe the distance between, since there is a manual error, since it's a drawing, here I'll take. So the distance between the latitudes, look at this, as you go from equator to poles, distance between the latitudes is almost going to remain same, but the distance between the longitudes is going to decrease because there is a convergence as you go towards the poles, right? So what we can conclude here is the distance between the latitudes as you go from equator towards the pole is going to remain same, but the distance between the longitudes is going to decrease as you go from the equator towards the pole. Probably this is the area how they can ask you the questions. Alright, apart from that also we have this time calculation and also date calculation. So for this latitude and longitudes are very much important, and this area, especially in the point of examination, you have to keep it in mind. Alright, so now here importantly, when we are talking about latitudes and longitudes, there are a lot of important latitudes that we have to keep it in mind, because they are the major one where the motions of the earth has expressed something that these latitudes are going to remained very important. Okay, and it's not only about the motion of the earth. Because of the climatic change and atmospheric circulation, we are coming up and landing with some of the latitudes which are very important. So the important latitudes we are considering is, so I'm talking about the important latitudes, very importantly, if I take this as the earth, very first important latitude, that is your 0 degree, is what we have is equator. Alright, so next we are taking a latitude that is almost 23.5 degree north, and similarly 23.5 degree south. Alright, so two important latitudes. We call this as Tropic of Cancer, this one as Tropic of Capricorn. Alright, so like that we have one more latitude, that is for 66.5 degree north, and here 66.5 degree south. We call this as your Arctic Circle. We call this as Antarctic Circle. Alright, so now why such type of latitudes are very important is something what we have to know. And we know that this is what we have is your Greenwich meridian. On the other side we have, this is your 0 degree. Opposite of that exactly we have 180 degree east and 180 degree west longitude, that is overlapping. So we call this one as your international timeline. The 180 degree and 180 degree west we call it as international dateline. Okay, so we call this as international timeline and international dateline. But I'm not going into the calculation of that one, but I'm trying to stress you about the what are the important latitudes and longitudes you have to know. Alright, so Earth actually rotates and also revolves. So there is a lot of motions of the Earth. Alright, so we have motions of the Earth. So when we are talking about the motions of the Earth, we have two types of motions. Yes, rotation and revolution. Alright, so rotation means it rotates basically on its axis. So this is the axis, this is the rotation. So Earth rotates from west to east. Revolution is nothing but around any object. So we have sun, so this is Earth, so it revolves around that in an anti-clockwise direction, around on an orbit, right? So because of this rotation and revolution, we can have day and night. All right, so we can have day and night. So what is that is making this latitudes and longitudes very important is very simple. I'm not going detail into motions of the Earth, but why I'm telling is why this topic of Cancer, topic of Capricorn become quite important for us. So talking about this rotation revolution, we all know that sun, if this is Earth and we have sun, where sun rays are coming and hitting on the Earth. So the very first point on which the sunlight comes and hits is because of the curvature is on the equator. Yes, this is simple because the shape of the Earth itself is like that. So we are having this sunlight coming and hitting on the Earth on the first point on the equator. Now this is your north pole, this is south pole. So if Earth is rotating from west to east and this is called as your axis, yes, there is no problem that here every time the sunlight is going to come and hit, and we will be experiencing this part of the Earth as day and this part of the Earth will experience night. So if there was no tilt in the axis, since if it is completely 90 degree, then the both sides would have equal day and equal night. But now this is not the condition. Alright, so here what is happening is Earth is, so whatever, if I want to tell you, the line which actually divides this day and night is what we call it as your circle of illumination. Okay, circle of illumination. Alright, so here such a circle of illumination is why it is important is, see, Earth axis is slightly tilted, that is north pole and south pole. Unlike it has to be a perpendicular, it is not perpendicular, it is tilted to almost 23.5 degree, or if I take from the orbital plane, it is 66.5. okay, now since it is tilted, now what is happening, we have sunlight where that is coming and falling on the Earth. So what I told you, unlike your equator, now what I can tell you is if I want to delete, since the axis is tilted, the equator is going to be like this, and your Tropic of Cancer, what I told, would be like this, and we have this Tropic of Capricorn. So this is equator, this is 23.5 degree north, that is Tropic of Cancer, this is Capricorn. Now observe here, the circle of illumination was like this, and now you can observe the north pole is in the day side, alright, and the southern pole is on the night side. Alright, so we are having the first sun rays coming and hitting on the first latitude, that is your 23.5 degree north, that is your Tropic of Cancer, instead of this 0 degree. So whenever we have this direct sun rays coming and falling and hitting on particular latitude, there we can expect a zero shadow, or we can call it as your overhead of the sun. So the overhead of the sun is coming and directly hitting in the condition where if the northern pole is beyond or within the day part, within the circle of illumination, I mean the day part, and southern pole is somewhere here. So this is what we are having as your north pole, and overhead of the sun is coming and hitting on the Tropic of Cancer. Alright. Now on the other hand, let us take the earth. This is your sun completely, and we are having the sunlight, and we are having the earth that has been tilted because earth has been revolved and it has come to this position. Okay, so we are having the circle of illumination that is divided. So we are having this as your northern pole, this as your southern pole. Alright, so we are having this as your equator now, and we are having the first point of sunlight that is coming and hitting is on this equator. This is 23.5 degree north and 23.5 degrees south. So we are having this south pole that is exposed to day, and this is exposed to night. So the southern pole is within the day part. So the first sun rays is going and hitting on the Tropic of Capricorn. So Tropic of Capricorn. So what I can tell you, your overhead of the sun is now in the 23.5 degrees south latitude. So the point you have to conclude here is the overhead of the sun concept is very, very important for you to understand the motions of the earth, summer solstice, winter solstice, and also the atmospheric circulation. So here, that is your trimordial cells. So overhead of the sun is whatever I told you. This is the point where exactly the point where the overhead of the sun is coming and hitting is on the Tropic of Cancer. So Tropic of Cancer is very important. That is where you are having 23.5 degree north, and if I come, it is coming on the Tropic of Capricorn, that is 23.5 degrees south. Yes, then you will be having two more positions. That is where it will be coming on the equator and also on the equator two times. That is where we call it as your equinox. I'm not talking about that one, but here I'm just telling you about the overhead of the sun, how it is going to be drifting from your Tropic of Cancer to Tropic of Capricorn. So this is where you will be having two important latitudes within which your overhead of the sun is going to go to and fro. Alright, so that is why these two latitudes becomes very, very important. Okay, so this is what I wanted to tell you. So this is your overhead of the sun. So the extreme limits where your overhead of the sun is going to be in the northern hemisphere is on the Tropic of Cancer, which is on the southern hemisphere, it is going to be in the Tropic of Capricorn. Okay, so these two things you have to know importantly. But when that is going, the overhead of the sun will come on the equator two times. Okay, on the equator two times. Alright, so based on this concept only, we will be having next the motions of the earth, that is your summer solstice and winter solstice. Since here the northern pole is more exposed to day, they will have longer days, southern poles will have longer nights. On the other hand, if it is coming into this position where southern pole is having more days, longer nights, and this is going to be having longer days and longer nights, that is going to be on the other hand we call it as winter solstice and summer solstice positions. So I'm not going into that, but as of now I'm just focusing on latitudes and longitudes, how this overhead of the sun is connected to the latitudes and longitudes, and how the 23.5 degree north and 23.5 degree south is going to be quite important. Alright, so with that I'll wind up. Thank you.